Welcome to Notes of Curiosity. Ever catch yourself looking up at the night sky and wondering how in the world anyone ever thought the Earth was the center of the universe?
I know, right?
Well, get ready for some serious mind-blowing, because today we're diving deep into worldviews,
Mhm.
an introduction to the history and philosophy of science, to uncover exactly that.
It's a fascinating book.
This deep dive is going to be a three-parter.
Oh, wow.
And today we're tackling the foundational ideas from the beginning of the book through chapter 8.
All right, sounds good.
So strap in because we're about to uncover some seriously thought-provoking concepts.
That's what I love about this book. It doesn't just throw scientific discoveries at you like isolated facts.
Right.
It takes you on a journey through how those discoveries were shaped by, well, the prevailing worldviews of their time. It's like peeling back the layers of history,
Yeah.
to understand how people arrived at those conclusions.
Even the ones that seem completely outlandish to us now. Okay, so the book kicks off with this idea of a worldview, and it uses this brilliant analogy of a jigsaw puzzle.
Oh, yeah, that's a good word.
Can you walk us through that?
All right, so imagine a giant jigsaw puzzle where each piece represents a belief you hold about the world. When you fit all those pieces together, they create a complete picture, your worldview. What's really interesting is that these beliefs are interconnected.
Yeah, they've got to be.
Some are core beliefs, like the corner pieces of a puzzle, and those are the foundational ideas that shape everything else. Then you have peripheral beliefs, those edge pieces that can change without disrupting the whole picture too much.
Gotcha. So let's take a trip back in time to ancient Greece,
Okay.
where the dominant worldview was the Aristotelian worldview. I can't even fathom looking up at the night sky and thinking, yep, everything revolves around us.
It seems wild now, but within the framework of their worldview, it actually made perfect sense. They believed that everything had a natural place and purpose. The earth, being made of heavy elements, naturally settled at the center, and the celestial bodies, made of this ethereal substance called ether, moved in perfect circles at a constant speed.
Reflecting the perceived perfection of the heavens.
Exactly. It all fit together beautifully, like a perfectly completed jigsaw puzzle.
Wow, talk about a cosmic plot twist.
I know, right?
But that raises a huge question. What happens when a piece of the puzzle doesn't fit anymore?
Yeah.
How do we even determine what pieces belong in the puzzle in the first place?
Right.
That brings us to another mind-boggling concept,
Mm-hmm.
truth.
Mm-hmm.
What makes something true?
That's a question philosophers have been wrestling with for centuries.
I-
The book explores two main theories. First, there's the correspondence theory, which says that a statement is true if it aligns with reality, if it corresponds to the way things actually are. Then there's the coherence theory, which argues that truth is about how well a belief fits within your existing web of beliefs.
Okay.
A belief is true if it coheres with everything else you hold to be true.
So it's not just about looking at the world and saying, this is what I see, therefore it's true. There's this whole other layer of how our existing beliefs color our perception of reality.
Exactly. And to illustrate this, the book throws in this thought experiment. It's straight out of The Matrix. Imagine living in a simulated reality where your senses are being manipulated. How could you ever be certain that what you're experiencing actually reflects the true nature of reality?
Hold on, I need to wrap my head around this. We're talking about questioning the very foundation of our reality. This is getting deep.
It really is. And here's where it gets even trickier. The book introduces this idea of philosophical conceptual facts, which are beliefs that are so deeply ingrained in a worldview that they seem like empirical facts, even though they're not directly observed.
Give me an example. I'm having trouble picturing this.
Take the ancient belief that celestial bodies move in perfect circles at a constant speed. That wasn't just some random idea they came up with.
Right.
It was considered a fact because it fit perfectly within their philosophical framework. They believed in this inherent perfection of the heavens, so it followed that celestial motion must also be perfect, represented by these unchanging circular paths.
So even scientific facts can be influenced by our worldview.
It's a pretty radical idea.
It is. But how do we move beyond our worldview to determine what's actually true? Is there a way to step outside our own framework and see things objectively?
That's where things get even more intriguing. The book dives into how we use evidence and reasoning to build our understanding of the world, particularly in science. We'll be exploring that in our next deep dive. And let me tell you, it's a real eye-opener.
I can't wait to unpack that.
Yeah.
But for now, I think we've given our listeners plenty to ponder. If even something as seemingly straightforward as the movement of celestial bodies can be influenced by our worldview, What does that say about our own understanding of the universe? It's a question worth mulling over. Stay tuned for part 2, where we'll delve into the tools of science and how they help us navigate this complex web of beliefs and evidence. Welcome back to Notes of Curiosity. Last time we were grappling with this whole idea that even scientific facts can be influenced by our worldview.
Yeah, it's like realizing the ground beneath our feet might not be as solid as we thought.
Exactly.
Yeah.
It kind of challenges us to look at not only what we believe, but how we got to believing those things.
Right.
Which leads us to this question of how science, a field that prides itself on objectivity, navigates this tricky terrain. So if our senses can be unreliable and our worldviews can color our perceptions, what tools does science actually use to figure out what's real and what's not?
Well, the book dives into two main types of reasoning that are, essential to the scientific process:
Okay.
confirming and disconfirming reasoning.
Okay, break that down for me. What's the difference?
All right, think of it like a detective working a case.
Okay.
Confirming reasoning is all about gathering evidence that supports a particular theory. It's like finding clues that point to a suspect.
But finding clues doesn't necessarily mean the suspect's guilty, right? There could be other explanations.
Exactly. And that's the crucial point. Confirming reasoning, also known as inductive reasoning, can never definitively prove a theory to be true.
Okay.
Even if you find a mountain of evidence that supports a theory, there's always a chance that new evidence could come along that contradicts it.
Right.
It's about building a strong case, but acknowledging that the case can always be overturned.
So it's like saying, based on the evidence we have now, this theory seems to hold up. But we're always open to new information. What about disconfirming reasoning? Is that like finding this smoking gun that proves the suspect's innocent?
Not quite. Disconfirming reasoning, also known as deductive reasoning, is about finding evidence that directly contradicts a theory. It's like finding, the suspect's fingerprints are on the murder weapon.
Right.
But the weapon was found in a location the suspect couldn't possibly have accessed. It throws their entire alibi into question.
So it's about finding those pieces of evidence that just don't fit with the theory. It seems like that would carry a lot more weight than confirming evidence. Does that mean disconfirming evidence can completely debunk a theory?
It would seem that way. But the book brings in another wrinkle: auxiliary hypotheses.
Auxiliary hypotheses, what are those?
They're the background assumptions that we make when we're testing a theory. To go back to our detective analogy, imagine you find those incriminating fingerprints on the murder weapon. But what if it turns out the suspect has an identical twin who could have planted the evidence?
That would definitely complicate things.
And that's exactly what auxiliary hypotheses can do in science. If we find disconfirming evidence, it doesn't automatically mean the main theory is wrong. It might just mean one of those underlying assumptions, one of those auxiliary hypotheses, was wrong.
Okay.
We might need to adjust our thinking about how the theory works, or consider alternative explanations for the evidence.
Okay, so science is a lot more nuanced than just shouting, "Eureka, I've found the truth."
Right.
It's about carefully considering the evidence, the reasoning, and all those underlying assumptions. It sounds like a constant process of refinement and revision.
The book gives a great example of this with the cold fusion controversy.
Oh, right.
In the late 1980s, scientists thought they had achieved nuclear fusion at room temperature,
Wow.
which would have been a revolutionary breakthrough. But when other scientists tried to replicate their results, they couldn't detect the expected neutron emissions.
So did they just scrap the whole idea of cold fusion?
Some scientists did, but others argued that the initial researchers might have been wrong about the specific mechanisms of cold fusion. They suggested that maybe one of their auxiliary hypotheses was flawed, not the core theory itself. They proposed alternative explanations and continued to explore the possibility of cold fusion, even though it remained highly controversial.
This makes me wonder how many of the so-called scientific facts that we just take for granted are actually built on shaky assumptions.
That's a fantastic question, and it leads us to one of the most, mind-blowing concepts in the book, the Quine-Duhem thesis.
Okay, I'm ready to have my mind blown. Hit me with it. What is this Quine-Duhem thesis all about?
Okay. In a nutshell, it argues that scientific hypotheses are never tested in isolation. Remember the jigsaw puzzle analogy of worldviews?
Yeah.
Well, the Quine-Duhem thesis kind of extends that to science itself.
So it's like saying each piece of scientific knowledge is connected to a whole web of other beliefs and assumptions.
Yeah.
Changing one piece could have ripple effects throughout the whole system.
Precisely. The thesis states that a single experiment can never definitively prove or disprove a theory because disconfirming evidence can always be attributed to a faulty auxiliary hypothesis. It's like finding a puzzle piece that doesn't quite fit.
Right.
You don't automatically assume the whole puzzle's wrong. You might just try adjusting the surrounding pieces to see if you can make it work.
Wow, this is really challenging my assumptions about how science works. It's not about finding these isolated facts and declaring them to be true. It's about understanding how those facts fit within a larger framework of knowledge
Ah.
and being open to revising that framework when new evidence emerges.
And that's what makes studying worldviews so fascinating. It's a
Yeah.
constant process of questioning, revising, and adapting our understanding of the universe.
So if even the seemingly solid ground of science can shift beneath our feet, where do we go from here? How do we navigate this whole complex web of beliefs and evidence to arrive at a more accurate understanding of the world?
That's exactly what we'll be exploring in our next deep dive as we journey through the historical shift from the Aristotelian to the Newtonian worldview.
I'm already intrigued. Talk about a paradigm shift. But for now, I think we've given our listeners plenty to chew on. If you're feeling a little unsteady after this deep dive, don't worry. That's a sign your brain is expanding. Stay tuned for Part 3, where we'll continue our exploration of worldviews and how they shape our understanding of the universe. Welcome back to Nights of Curiosity. We've been on quite a journey through this world of worldviews.
We have.
Started by questioning how anyone could have believed the Earth was the center of the universe,
Right.
then jumped down this rabbit hole of questioning reality itself.
Yeah.
And last time we grappled with this mind-bending idea that scientific theories, they're never tested in isolation. It's enough to make your head spin.
It really challenges us to, think critically about what we believe and why. It's like realizing that even the seemingly solid ground of scientific knowledge is built on, well, a network of interconnected beliefs and assumptions.
So where do we go from here? If
Mhm.
even scientific facts can be influenced by our worldviews,
Yeah.
how can we ever be confident in our understanding of the universe?
That's the big question, isn't it? And it's a question that the book tackles head on in this next section, where we explore a really pivotal moment in the history of science, the transition from the Aristotelian to the Newtonian worldview.
Ah, yes. From a stationary Earth at the center of it all to a solar system with planets in motion around the sun. Talk about a paradigm shift. I'm really curious to see how that all unfolded.
Yeah.
What caused people to abandon a worldview that had been accepted for centuries?
Well, it was a gradual process driven by new evidence and a willingness to kind of challenge long-held assumptions.
Yeah.
The invention of the telescope played a key role, allowing astronomers to observe the heavens in, unprecedented detail. Galileo's observations of Jupiter's moons, for example, provided compelling evidence against that geocentric model, showing that not everything revolved around the Earth.
So new evidence started to poke holes in the Aristotelian jigsaw puzzle, so to
Yeah.
speak. But was it just about new data? Or was there something, I don't know, more profound at play?
It was a combination of factors, really. As astronomers gathered more data, they started to realize that the Aristotelian worldview couldn't adequately explain, well, what they were seeing. They needed a new framework, a new set of core beliefs to make sense of the universe.
And that's where Isaac Newton comes in, right?
Yes.
With his laws of motion and universal gravitation,
Sure.
he provided that new framework.
Exactly. Newton's work revolutionized our understanding of the universe.
It did.
It explained not only why objects fall to the ground, but also why planets orbit the sun in elliptical paths. It provided a comprehensive and elegant model that fit the observed data far better than the Aristotelian worldview ever could.
It's fascinating how a shift in worldview can have such, I don't know, profound implications for our understanding of the world. It makes you wonder, are there any aspects of our current worldview that might be completely overturned by future discoveries?
That's the beauty of science and of knowledge in general. It's a constantly evolving process.
Right.
We're always gathering new information, refining our theories, and adjusting our understanding of the universe. What we hold to be true today might be challenged tomorrow, and that's okay.
Yeah.
It's what keeps us curious and drives us to explore further.
Well said. I think that's a perfect note to end on. As we wrap up this deep dive into worldviews, I want to leave you with a thought-provoking question. What facts do you hold to be true? And what evidence supports those beliefs? Are your beliefs based on empirical observations, or are they more deeply intertwined with your broader worldview? It's something to ponder as we continue our exploration in future deep dives. Until then, stay curious.